Everything began approximately 4.6 billion years ago, at a time when the solar system had not yet even become a star. Space was filled with a vast cloud of gas and dust. Most of this cloud consisted of hydrogen and helium. However, it also contained heavier elements such as iron, silicon, oxygen, and carbon. This was precisely the raw material from which Mars would form. This cloud likely began to collapse due to the shock wave from a nearby supernova explosion. As the Sun was born at the center, the rotating, disc-shaped structure around it, known as the protoplanetary disk, became the region where planets would take shape. Mars began to form in the inner regions of this disk, close to its present-day orbit. However, Mars's story progressed more rapidly than Earth's. The primary reason for this was Mars's smaller size. Smaller bodies lose heat more quickly, but they also form more rapidly. Scientists believe that Mars's core and overall structure were largely completed within just 2 to 4 million years. On a cosmic timescale, this is the blink of an eye. During this period, Mars was subjected to countless collisions. Planetesimals collided with one another, merged, and gradually formed larger bodies. Mars grew within this chaotic environment, but it never became as large as Earth. One of the key reasons for this was the powerful gravitational influence of Jupiter during the early stages of the solar system. Jupiter effectively swept away much of the material in the Mars region, preventing Mars from growing further. For this reason, Mars is often described by scientists as a half-finished planet. As Mars grew large enough, its interior began to heat up. The energy produced by the decay of radioactive elements and by frequent collisions melted the planet's interior. As a result, Mars differentiated into layers, much like Earth. At the very center, a core rich in iron, nickel, and sulfur formed. Compared to Earth, Mars has a relatively larger core, meaning that the core occupies a greater proportion of the planet's total volume. This allowed Mars to possess a strong magnetic field during its early history. Above the core lay the mantle, dense yet capable of flowing over geological timescales. The mantle was the source of the planet's volcanic activity. On the outermost layer, a solidified crust formed. Mars's crust is much thicker than Earth's crust. The reason for this is that active plate tectonics never developed on Mars. While Earth's crust is constantly in motion, Mars's crust has remained largely stable. This stability has allowed surface features from billions of years ago to be preserved. During this early period, Mars was geologically extremely active. Enormous volcanoes formed, lava flowed across the surface, and the planet was, in many ways, a seething world. Today, Mars is a cold, dry planet with a thin atmosphere. However, in the past, conditions were very different. Early Mars possessed a thick atmosphere, composed largely of carbon dioxide, water vapor, and nitrogen. Volcanic activity continuously released these gases into the atmosphere. When the atmosphere was dense enough, surface temperatures increased, creating conditions suitable for liquid water. The dried-up river channels, deltas, and lake remnants we observe on Mars today are silent witnesses to this era. Scientists believe that Mars may once have hosted long-lived lakes and even large bodies of water similar to oceans. At this point, a critically important question arises. Were there conditions suitable for life on Mars? Early Mars met all three of the primary requirements for life: water, energy, and essential chemical elements. This makes Mars one of the strongest candidates in the search for life beyond Earth. One of the most important events that shaped Mars's fate was the loss of its magnetic field. Initially, Mars had a molten, fluid core, which generated a strong magnetic field for the planet. This field protected the atmosphere from the solar wind. However, because Mars is relatively small, it lost its internal heat rapidly. Over time, the core solidified and the magnetic field weakened. Once the magnetic field disappeared, charged particles from the Sun gradually stripped Mars's atmosphere away into space. As the atmosphere thinned, surface pressure dropped, water either evaporated or froze, and the planet cooled rapidly. Mars transformed from a potentially habitable world into the barren planet we know today. Today, Mars is a planet that clearly displays its past on its surface. The gigantic volcano Olympus Mons is the largest volcano in the solar system. Valles Marineris, on the other hand, is a vast canyon system stretching thousands of kilometers. Spacecraft sent to Mars continue to provide more clues about the planet's history with each passing day. Minerals found in the soil, rocks that have interacted with water, and traces of methane detected in the atmosphere all suggest that Mars still has many stories left to tell. The formation of Mars is not merely the story of a single planet. It also helps us understand why Earth is habitable. Mars reminds us of this simple truth. When the right conditions are lost, a planet's fate can change completely. Perhaps by looking at Mars, we can better appreciate how delicately balanced our own planet truly is.